Hi folks, today we're looking at the Math 621B Chapter 4 assignment prep from 2021. In the video description, I'll put a PDF of the solutions to this and also a PDF of just the questions. And you can also find in the video description a link to a video that covers the general concepts of this chapter. Though if you do this assignment prep, then you will have covered all these things on the checklist, so sketching angles in standard position, etc. Let's dive right in. So we're first going to draw a unit circle, or whatever we use to organize our trig values. I like this unit circle thing, so I'm going to make it. There it is. There's the quarter circle. And what I'm going to do first is just draw in my angles. This is 0 degrees, which would also be 0 radians. This would be 45 degrees. And I can do this a little bit better on a piece of paper than I can on the iPad. But the other angles that we care about are 30 degrees, or pi over 6, 45 degrees, which is pi over 4, 60 degrees, which is pi over 3, and 90 degrees, which is pi over 2. The easy points to get here, since it's a unit circle, would be 1, 0, that's all the way out and none the way up, and 0, 1, all the way up and none the way over. I guess that leaves us these other ones, and they're all going to be coordinates over 2. We'll zoom in a little more. So that's over 2, something over 2, something over 2. And the way that we get these values is by thinking about the Jackson 5 song. I'm not going to sing it because YouTube's real particular about copyright claims. But it's as easy as 1, root 2, root 3. Okay? Or you could think root 1, root 2, root 3. And the y, same thing. 1, root 2, root 3. I really think you should put the tangent values on the outside too, so I'm going to do tangent in red. And they come from y over x. So 0 divided by 1 would give you a tangent value of 0. Up here, 1 divided by 0 would be undefined. This one at 45 degrees is going to give you a tangent value of 1 because anything divided by itself is 1. And then you might want to memorize the other ones, or you can do the division yourself. So you get 1 over root 3 at 30 degrees and root 3 at 60 degrees. 1 over root 3 can also be rationalized as root 3 over 3. The other things that we want to know here is that on the unit circle, the x values are cos theta, the y values give us sine theta, and as we said up top, tan is y over x. On the unit circle, they're all positive in the first quadrant, sine's positive in the second quadrant, tangent's positive in the third, and cosine in the fourth. Those are really the big ideas. Next, we're going to sketch some angles in standard position. So 120 degrees. Here we go. 120, that would be 90 to here. There's about 120. 5 pi over 3. So here, right above, we can see pi over 3 is 60 degrees. So this is really 560 degrees. 560 degrees, or 300 degrees. If that helps you out better, that's fine. Or maybe you're getting comfortable with radians, and you can just draw that. It's going to be more than 270 degrees, but less than 360. So it'll terminate in quadrant 4. The next one, 405 degrees. That's going to be bigger than a revolution. So 1 time round is 360, and then really another 45. Oh wow, look at the iPad attempting to make a circle for me. But no, I stand by my ridiculous circles. All right, and the last one, negative 3. This is a little harder. But if I were to draw negative pi, would be all the way over here. Remember, negative angles are in a backwards direction. Negative 3 is just a little smaller than negative pi, because pi is about 3.14. So we'd be looking at something like this. Almost 180 degrees in the negative direction, but not quite. The next thing we'll do is find some reference angles. And if we're ever stuck for reference angles, I think the easiest thing to do is just draw them out. So here we go. There's 220 degrees, looks like this. Okay. And so the reference angle, just to be real clear here, is the angle with the x-axis. How big would that be? Well, it would be 180 degrees gets you to here. and then another 40 gets you to the end. So 40 degrees for that reference angle. B, 7 pi over 6. So again, I might draw it. So this is pi, or 6 pi over 6. Here's another pi over 6. Okay, so this little bit here, this reference angle, will be just pi over 6. For the common angles, it'll always work out that if you have a denominator of 6, your reference angle will just be pi over 6. Now, if you wanted to do that whole thing in degrees, that's absolutely fine. You'd say it's 210 degrees. You'd find the reference angle is 30 degrees. But since the question's given in radians, you would then go and convert it back to radians. So I'd be looking for a radian answer in B. That brings us to number 4, finding exact values of sine, cosine, and tangent. So let's just refresh our memories here. For any point in space, the cosine of the corresponding angle in standard position is x over r. The sine is y over r, and the tan theta is y over x. And what does this r mean? Let's see. I want to draw this point. So 2, 3 is somewhere over here. What we mean by r is the length of this ray, or this arm that comes out. Because really this is a triangle that's 3 tall and 2 wide. We just can think of it in terms of its x and y coordinates. The formula comes from Pythagorean theorem. The radius is going to be square root of x squared plus y squared. Okay, so that'll give us 2 squared plus 3 squared. I'm being careful when I sub in to put them in brackets. I could probably get away without doing that here because they're positive values, but it's a good habit to be in. So that gives me root 13. Now, 2 reasons you wouldn't put that into your calculator. Number 1, this is the non-calculator section. Number 2, it's as exact as it's ever going to be right now. If you get a decimal version, it's going to have infinitely many decimal places. You can never get it better than just writing it's root 13. So we can head up now. X was 2, r is root 13. There's cosine. Y is 3, r is root 13. There's sine. Y is 3, x is 2. Now you can, if you want to, you can rationalize these ones. And you do that by multiplying by root 13 over root 13. And this would become 2 root 13 over 13. I only put the irrational answers in the answer key, but either one is fine. There we go. Those are other alternate answers. And rationalizing comes from just multiplying by root 13 over root 13. Let's do another one. Same idea here. So I probably should have started by just drawing these points. If I know the points, I mean, that might help me. Okay. And I'm just curious here, what is the sine, cosine, and tangent of this angle here? So again, cos theta is x over r. Sine theta is y over r. And tan theta is y over x. We find r by going root x squared plus y squared. So here I do have to be careful. I'm going to put in negative 6 and square it, and negative 8 and square it. That's going to give me the square root of 36 plus 64, or the square root of 100, colloquially known as 10. So in this case, we do get a nice whole number radius, and we can just plug and chug up here. X was negative 6, radius is 10. You could reduce that down to negative 3/5. If you wanted to, I guess you could call it negative 0.6. Though that seems a little weirder on a non-calculator section. This would be negative 8 over 10, which reduces down to negative 4/5. Or again, negative 0.8 if you wanted to. And then y over x is negative 8 over negative 6. Now, a negative divided by negative is a positive, so that's the same as 8/6, or 4/3. Okay. There are all our trig ratios. Here it does not ask us to actually find the angle, so we won't. All right, convert the following angles from degrees to radians or vice versa. So convert it to the other one. The big guiding idea here is that pi radians is 180 degrees. So 60 degrees is going to be 1/3 of 180, or pi over 3. Now this stuff is also on your unit quarter circle. 60 degrees and pi over 3, you can see them right here. Okay, they're given to you in their conversion in the unit circle, or unit quarter circle. Heading back here, 7 pi over 4. How I would think about this is that we've got 7 pi over 4s. Now again, you could go to your unit quarter circle, and it will tell you that pi over 4 is 45 degrees. This is not the only way that you can do these conversions, but I think it's pretty slick. If you can get them to relate back to common angles, it goes quickly. So I would be thinking that negative 150 is negative 5/30s, or negative 5 pi over 6s, because 30 degrees is pi over 6. So in radians, it's negative 5 pi over 6. The next one, we've got 2 pi, so that's going to be 2 times pi, which is 180. And this is a really common one. 2 pi is 360. And lastly, you might be able to do this one by inspection, but if everything else kind of gives away on you, you can use a conversion factor. So we want to get it in radians, so I'll multiply by pi over 180, and that'll give us 110 pi over 180. That reduces down to 11 pi over 18. Now it does say here, use exact values. So that's exactly what it is. If you wanted to get an approximation, you'd throw it in your calculator. But again, it says exact, so we'll keep it exact. Also, in this question, you're not allowed access to your calculator. All right, coterminality. So coterminality has to do with whether angles end up in the same place. So there's 210 degrees. I mean, what's a coterminal buddy to it? Well, this one right here, negative 150. It's not the only coterminal negative angle to it. Coterminal positive angle, that would be maybe an extra revolution. So that would be 210 plus 360, which could give us 570. If you didn't want to draw the picture at all, I guess what you could do is just say, I'm going to subtract 360 from 210. I'm going to subtract a revolution. That'll give me negative 150. That's a negative angle. That's coterminal with 210. And over here, if I want to get a positive one, just add 360. So that'll give me 570. Whether you want to draw a picture or not, totally up to you. Let's try the next one without drawing a picture. So let's get a positive angle. I could add 360 degrees, which is 2 pi. Okay, now remember, we're going to have to get a common denominator to add a 2 pi on. So let me think of that as 4 pi over 2. That's what 2 pi is. And that'll give me 13 pi over 2. That's one possible angle that's coterminal with 9 pi over 2. To find a negative one, I could start subtracting off some 2 pi's. And again, I'm going to think of that 2 pi as 4 pi over 2. So what am I going to get? I guess I get 5 pi over 2. Hold on. That's not negative. Okay, so we could just subtract off another 2 pi from it. Or another, again, think of it as 4 pi over 2. All we're doing is subtracting off revolutions. So these angles are going to end up in the same place. That'll give us 1 pi over 2. Oh man, that's still not negative. Well, that's okay. Just keep going backwards. So again, subtract off another 2 pi. And that'll give us, again, we have to think of that as 4 pi over 2. That'll give us negative 3 pi over 2. Good. There's a possible answer out of the infinitely many. All of these angles are coterminal with 9 pi over 2. So let's just show what that means. This would be 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2 is right here. Okay, it's 2¼ revolutions. You could think of it as 810 degrees. But these green and these red angles that I've drawn here, or that I've written down, they're all ones that end up in the same place. That's what coterminal means. They end in the same place. All right, number 7. Number 7 is kind of the question that often gets botched the most, because people get good or relatively comfortable with solving equations, and then they forget what these ones are asking. These ones are giving you the angle and just asking, like, what is the point on the unit circle there? What's going to be the sine value of 60? So I'll see this often, is pi over 3. No, no, no. That's just 60 written in radians. What we're asking for here is something to do with the unit circle. So what I would do as my first step is say 60 degrees, let me sketch that. Because there's no question here what the angle is. 60 degrees. This happens to be in the first quadrant, and I'm just thinking about, okay, well, what's the y value on unit circle? I could go back to my unit quarter circle. If I go to 60 degrees, I find the y value is root 3 over 2. So it's going to equal root 3 over 2. And I have to think, in that quadrant, because again, there's no question what quadrant I'm in, is sine positive or negative? They're all positive in quadrant 1, so it's going to give us root 3 over 2, positive root 3 over 2. And we're all done. So similarly, in the next one, 4 pi over 3. If you want to convert this to degrees and make it 240 degrees, go for it. I'm feeling comfortable with my radians here. And so it looks something like this. It terminates in quadrant 3. Its reference angle is going to be pi over 3. And again, if you do this in degrees, you'll just find that reference angle is 60 degrees. It's the same thing. So now we go to the unit quarter circle. What's the tan value for pi over 3? Okay, so again, 60 degrees or pi over 3. I've got it right here, that root 3. So that's the number that we need. And let's just check it out. Is tangent positive or negative in this quadrant? It's positive, right? It's in that T quadrant. So our final answer is going to be root 3. We're just finding the values of these. You could double check it with your calculator, but you wouldn't necessarily have that on the test. So here's the next question. Tan of negative 2 pi over 3. So that's negative 120 degrees. Kind of looks like this. And this is one people often botch. The reference angle is still pi over 3. So we just found the tangent of pi over 3. It was root 3. Now, people will often say, since the angle's negative, the answer has to be negative. No, no, no. It has to do with what quadrant you're in. And you can see that we're in quadrant 3 here. Tangent is positive. Really, the stick is in the same place as it was in B, the angle that we're talking about, or the coterminal angle that we're talking about. So the answers to B and C are going to be the same. 3 pi over 2. Again, I'm going to draw this angle. So 90 degrees is 1 pi over 2. 180 is 2 pi over 2. This would be 3 pi over 2. And if I'm just thinking about the unit circle, I mean, at that point, this is the point 0, negative 1. I could also put some other points on. If you get angles that are right on the axes, I would just think about the circle. Okay. So we're talking about this point right here. And since it's cosine, we care about what its x value is. Well, its x value is 0. Okay, so at that angle, the x value on the unit circle is 0. Therefore, the cosine of 3 pi over 2 is 0. Now we move on to some ones that have reciprocal trig ratios. So the first thing I'm going to do is think of this as 1 over the cosine of negative 60. Okay? And I guess what we should mention here is that cosecant theta is 1 over sine theta. They each get a co-buddy. Secant theta is 1 over cosine theta. And tan theta is, sorry, cotan theta is 1 over tan theta, though it does work the other way around too. Let me draw that properly. Cotan theta is 1 over tan theta. So here I can rewrite this as 1 over cos negative 60, and I feel a lot more comfortable talking about the primary trig ratios. Cos of negative 60. All right, let me draw a negative 60. It looks like this. It's going to have a reference angle of 60. And I can go and figure out that the cosine, or the x value at 60 degrees, from my unit quarter circle, is a half. I can also figure out that cosine is positive in this quadrant. Now, that means that you can now rewrite this as 1 over a half. That's a horrible way of writing something. 1 over just means the reciprocal, and the reciprocal of a half is going to be 2. So you can just flip in the end. You find the cosine's a half, that means the secant is 2. Okay? If you really want to do 1 divided by a half, that means 1 divided by a half, which means 1 times 2 over 1, and you can justify that this is going to give you 2 in the end. But again, just flip. A couple of things to remember are that in this context, 0 and undefined are reciprocals of each other, because 0 would come from something like this, and undefined would come from something like this. So let's check out what's going on with cosecant of pi. I'm going to think of it as 1 over sine pi. And I'm going to think about the sine of pi. Okay, so again, it's one of these angles that's right on the axes. Pi is right here. Be this point, negative 1, 0. Again, if you wanted to, you could put in the other points on the unit circle. Just sort of the polar points. Now, the sine of pi is this y value right here. So the cosecant of theta, or of pi rather, is 1 over 0. And 1 over 0 is undefined. Similarly, we got the cotangent of 90. So that's 1 over the tangent of 90. We're going to think about the tan of 90. And again, it's right on the pole here of 0, 1. Tan is y over x, so it's 1 over 0. So it's undefined. Or you could think of it as 1 over 0. Okay. And we're going to think in this context that 1 over undefined, that gives us 0. 0 and undefined are reciprocals of each other. You could also think of that by saying, okay, tan 90 is 1 over 0. Flip it upside down, you get 0 over 1. Hey-yo, that's 0. A last way you could think of this is that cotangent, remember we said tan is y over x. Cotangent could be x over y, just a reciprocal. But I guess big ideas, 0 and undefined are reciprocals of each other in this context. Now, there are actually a bunch of ways that you can end up with an undefined quantity, but the way that we will in these trig ones is through division by 0. So that's why we get this property. All right, on to the equations. So you're going to need your unit quarter circle to figure out reference angles. I just want to recap the process. Reference angle, choose your quadrants, sketch, and then your solutions, however many there are. Here we're dealing with just the regular first revolution. So it's first positive revolution. We are working in radians though. So the very first one, sine theta is negative root 3 over 2. Sine is y on the unit circle. Let's figure out where we have a y value of root 3 over 2. Ah, there it is again. So we're still talking about 60 degrees here, but let's write it as pi over 3. Next thing we're going to do is choose quadrants. This is where the negative comes into play. So to find the reference angle, we just cared about this much. Now to find the quadrants, we care about the fact that it's negative. Sine is positive in quadrants 1 and 2. It's negative in quadrants 3 and 4. And lastly, we're going to draw this thing. How good does your drawing have to be? I mean, just not terrible. But your reference angle needs to be with the x-axis. I can't say that enough times. X-axis is what you measure your reference angle from. Okay, now we just have to write the answer. And I'd give you 2 out of 3 for just having the picture of it. So let's see. There's one of the answers. How would we define that? That is 180 degrees plus another pi over 3. Okay. So that would make it, let's see, 1 pi is like 3 pi over 3. There we go, 4 pi over 3. I'm going to grab another color and do the other one that I come across. So if I were doing this in degrees, I'd think it's 360 degrees minus a bit. Well, let's just do that in radians. That would be 2 pi minus that pi over 3. Okay. And again, we need a common denominator, so 2 is 6 over 3 and gives us 5 pi over 3. Those are our 2 answers in this domain. If you have cosine values or sine values that are 0, 1, or -1, I recommend that you can skip all these steps because it can be hard to deal with reference angles of 0 or 90, and it can be difficult to assign quadrants. So right here, we're wondering, where is cosine -1? Let me just draw a circle. And on that circle, I'd have a bunch of points, the simple points. -1, 0, and 0, -1. So let's see. What point would correspond to a cosine of -1? The spot where x is -1. And then we might also think, well, okay, then what is that angle? To get over there, that's 180 degrees, or pi. So if you have cosine or sine values of 0, -1, or 1, just go with the circle. And finally, some reciprocal ratio shenanigans. So tangent, or cotangent is just 1 over tangent. I'm just going to write this out like that. I haven't changed the value of anything. I just wrote cotangent by its other definition. Now flip. So tan theta is going to be -1 over root 3. Having it as a primary trig ratio is going to be easier to work with. And we go and we find the reference angle. So again, off to the unit quarter circle. Where's there a tangent value of 1 over root 3? Hey yo, it's at 30 degrees, or pi over 6. So reference angle of pi over 6. That's kind of my first little step. And the hope is that these steps start to become second nature. Choose your quadrants. Tangent's negative in these 2 quadrants. You can go straight from this equation because they're equivalent to each other. So now let me draw those. I've got pi over 6 in this quadrant and pi over 6 in this quadrant. What are those angles in standard position? Well, this one right here would be pi minus pi over 6. And this one right here would be 2 pi minus pi over 6. Okay. And then we just have to work those out. So this means 6 pi over 6. That's 5 pi over 6 for our answer. The red one, 2 pi, would be like 12 pi over 6. So we'd get 11 pi over 6 for our answer. Okay, moving on. We've got solve this equation. Now this is an annoying one. It's got a 2 in front of the sign. But whatever stuff is weird, we just try and turn it into something that's familiar. That is a general mathematical sort of tack. So again, once I've got sine theta as a half, I find the reference angle. And we can go to that unit quarter circle and figure out that it's 30 degrees. This one's in degrees. We're going to choose quadrants. So again, I think sine is positive, so it's going to be these 2 quadrants. and I can draw my answers. Okay. And I just have to give them in standard position, but I've got some restrictions here. Check out that domain. In the positive direction, I can only go up to 90 degrees. So I'm going to run into a solution at 30 degrees. That's great. But I'm only allowed to keep going up to 90 degrees. I'm not going to run into another solution. Well, that's okay. Let's see what happens if we go backwards. I can go backwards up to 270 degrees. So here would be negative 90 degrees, negative 180. Oh, going to run into a solution right there. That's 180 plus 30, but in the negative direction. And lastly, I guess we could keep going with this and say, are we going to run into another one up to here? No, we're not. You might say, oh, we might run into one here, but that's too far. That's beyond negative 270. And the iPad really wants to make that a real circle. So those would be our two solutions on that restricted domain. You have as many solutions as you have times that you run into the, say, sticks or terminal arms of your drawing. I really think that the drawing helps you not make goofs on these. And lastly, give the general solution to cosecant equals negative 2 over root 3. So we're not going to be fooled by you, cosecant. You are 1 over sine. There's negative 2 over root 3. Okay, flip them upside down. Gives us negative root 3 over 2. Go through our steps. Reference angle is going to be 60 degrees or pi over 3. It does ask for radians here. Sine's negative, so we're going to choose quadrants down here and here. I'm going to draw my solutions. I'm going to try not to do a terrible job in those quadrants. Again, reference angle with the x-axis. Now, when we say general solution, we mean that any angle that terminates in either of those places is a solution. So, I mean, for example, you could have this answer as a solution. But you could also have, let me grab my favorite color, you could also have this angle as a solution because it ends in the same place. So how many solutions are there in all? There are infinitely many. What I think you should do is grab the solutions that occur in the first positive revolution, just as sort of a convention. So this first one here is going to be, let's think of this, that would be pi plus pi over 3. So 4 pi over 3. And I'll grab a different color. This next one over here, that would be like 2 pi minus pi over 3. Okay, so that's 5 pi over 3. Those are the first positive solutions. And then we can turn them into general solutions by just adding on a statement that means plus whatever number of revolutions. 2 pi, which is a full revolution, times n, where n is an integer. So you could put in values like 1, 2, 3, a million, 500 million. You could also put in 0, and you could put in negative numbers like negative 1, negative 2, and so on. So in that way, it can also go backwards. It can have a negative answer. You cannot put in numbers like 1.2 because that wouldn't give you an extra full revolution. It would give you a full revolution and a little bit. So to end up in the same place, we need to be adding on multiples of 2 pi. If this were in degrees, you'd say plus 360n. So all we did here for a general solution is did the regular first revolution solution and added on these things that I've drawn in black, the plus 2 pi n, where n is an integer. That gets us through the non-calculator stuff. We can go to the calculator parts. So convert the angles and give your answer correct to 3 sig figs. So if we want to go 2 degrees, we would times by 180 over pi. Okay. And I won't pull up my calculator, but if you do that, you should end up with 96.9, and that'll be degrees. And it's worth having a decent calculator. If you want to go 2 radians, then you want to divide out the degrees. You go 39 times pi over 180. That'll give you 0.681 radians. Now, radians do not need a unit. They just need the absence of a degree. And lastly, 1. Now, remember, this 1 is 1 radian because it does not contain degrees. So let's put it in degree form. And if you do that multiplication, or just 180 divided by pi, you'll end up with 57.3 degrees. That's how big 1 radian is, roughly. Okay, but if you put all its decimals there, they'd go on forever because there's a pi involved. Number 2, negative 6/8 on the terminal arm of some angle in standard position. Find that angle in degrees. Oh my gosh, they told me a point. I am going to draw that point. Okay, because I feel like I'm less likely to botch it if I draw it. So there's the point. It's on some terminal arm, and I'm wondering, what is this angle theta here? I'm going to need one of my trig ratios to help me figure out what the reference angle is. Okay, that's what I'd like to know. If I could figure this out, then that would be nice. And I'm going to have to use some sort of inverse trig to find the reference angle. The easiest ratio to use is this. The fact that tan theta is y over x, or 4/3. So the reference angle is going to be the inverse tan of 4/3. If it had been negative 4/3, I'd still go inverse tan of positive 4/3. Because I want to make sure that I get a positive acute angle for my reference angle. If you throw that into your calculator, you'll get 53.1 degrees. If you don't get 53.1 degrees, you might have forgotten to use inverse tan, or more likely, you might be in radian mode. This question asks for degrees, so make sure you're in degree mode. Once we know that, that means that the full angle here must be 180 plus 53.1 degrees, which I'm just going to give to 3 sig figs, but you can give more if you want, or 233 degrees. Determine whether the points lie on the unit circle. The equation of the unit circle is this: x squared plus y squared equals 1. So really, we're just wondering, like, do these points work in the unit circle? Now, I could also think about this, like, just as a matter of course. The unit circle looks like this. There's 1. Is there any chance that 1, 1 lies on that circle? No, it's too far out. But we can show it algebraically, too. So all I'm going to do is plug in the values 1 for x and negative 1 for y into the formula over here, x squared plus y squared equals 1, and see if it works out. So 1 squared plus negative 1 squared is one of my favorite mathematical symbols. Does that equal 1? Let's see, you get 2 on the left. Ooh, that's not equal to 1. No, this point doesn't work in the equation for the unit circle, so it's not on there. We try the same for the next one. Ooh, I wonder if I put 0.6 in for x, again, into this equation, and negative 0.8 in for y, I wonder if that will give me 1. Okay, now, 0.6 squared is 0.36. Negative 0.8 squared is going to be a positive. Remember, I put those in carefully using brackets. And then we get 1 is 1. Yes. Okay, it satisfies the equation. So the answer to B is going to be yes. C, same sort of thing. You may have some intuitive grasp at some point here. Just say, nah, this isn't going to work out. But let's show it. Does that work out? Let's see, that's 0.25 plus 0.25. Does that equal 1? Heck no. 0.5 is not equal to 1. Nah, this point's not on the unit circle. All right, number 4. You're just typing these into your calculator. The sine of 23 degrees, that's going in. Your calculator needs to be in degree mode. So you get 0.391 for what it's worth. What that means is that for 23 degrees, you go up 0.391 on the y-axis for every 1 that you travel on the hypotenuse. B, sine of 23, haha, no degree sign. So this one is in radians. Again, you'll just plug it in and you'll get negative 0.846. I feel like these questions are gifts, but often they get botched because people are not paying attention to whether we're in radians or degrees. Cosecant of 23 degrees. So that equals 1 over the sine of 23 degrees. Oh, wow. That is completely illegible, even by my iPad standards. Let's try that again. 1 over sine of 23 degrees. Okay. And you'll just type that in your calculator. It should give you 2.56. If you have a two-line calculator or decent calculator, then it's all one step. And if you don't, I recommend that you get one. This one, again, this is in radians. Now, be real careful here. There's no guarantee that the answer here is negative. The angle is negative, so it's going backwards however big negative 23 radians is. It's pretty big for an angle. But I don't really care what it looks like because I'm just going to type into my calculator 1 over 10 negative 23. That should give me to 3 sig figs negative 6.630. Okay. So just type them in. Nobody's got a cosecant or cotangent button, so you have to do the flippy for yourself there. And that brings us to the sort of the last part. We're doing some equations where we've got our calculator. Just to be clear here, when we do an equation, it's just wondering what angles give you a cosine of negative 0.8. So I'm going to think about my reference angle. And to get that, this is not on the unit circle, so I have to go inverse cos of 0.8. And if I type that into my calculator and I'm in degree mode, it should give me 36.9 degrees. That's the only difference between the equations without a calculator and with a calculator. So here, I mean, you don't even really need to know the unit circle. We're going to choose ourselves some quadrants. So where is cosine negative? Okay, that's what we're looking at. It's negative over here and here. So let me draw this. 36.9 degrees and 36.9 degrees. That drawing will make it harder for me to botch these answers. So one of these answers is going to be 180 minus 36.9 degrees, and one's going to be 180 plus 36.9 degrees. And so to 3 sig figs, 143 and 217, you can show greater accuracy if you'd like. I think one thing worth mentioning here is that you can check when you have your calculator. I can check, like, if I put in that 143, will it really give me negative 0.8 like it's supposed to? And I'll go to a calculator here. I'm on a TI-84 emulator called Calculate 84, which is free, and I'd highly recommend if you're looking for an iPad or iPhone compatible calculator. Anyways, we're saying we just want to figure out what the cosine of 143 is and what does it really give us, negative 0.8. I'm checking that I'm in degree mode. Yep. And it tells us that the answer's about negative 0.8. There's a little bit of rounding error. We could do the same thing with the other answer that we found, which was 217, I think. Same thing. It basically gives us negative 0.8. So we've done a good job. On a part with the calculator, you can do this kind of checking. A couple of more equations. So this one's annoying in that it has stuff on both sides. Let's just subtract 5 from both sides. We get 2 cosecant theta equals 5, or cosecant theta equals 5 over 2. We've isolated our trig ratio. Now we get to deal with the fact that we don't love this trig ratio, so let's rewrite it as 1 over sine theta is 5 over 2. And now flip it so that sine's on top. So we get sine theta over 1 is 2/5. In this case, we're ready to get started with our process. Find the reference angle. Inverse sine of 2/5. Don't have to worry about the negatives. I should be in radian mode here. So 0.412 is what I get. I'm going to choose some quadrants. Oh, I don't know why it gave me that arrow. Anyways, ASTC. Sine is positive, so it could be in these two quadrants. So let me draw it. I'm not really that concerned about how nice my drawing is, as long as it's in the right quadrants. 0.412 and 0.412. Okay. And now let's just name those angles. So this first one here is pretty straightforward. It's 0.412. This other one over here is pi minus 0.412, which would be about 2.73. Those are our two answers because we're just dealing with the basic domain, the first positive revolution, or 0 to 360 degrees. A general solution and a weird domain. That's what we've got left here. So general solution for tan theta equals -5. Again, hopefully this process is starting to look familiar. Find a reference angle. And I'm going inverse tan of 5. I always take the positive for finding that reference angle. I'll throw that in my calculator. My calculator is going to be in radian mode. Get 1.37. I'm going to choose some quadrants. ASTC. Check it out. Tangent's negative, so we must be either in the second or fourth quadrants. Let's draw our answer. And again, I don't really care about scale here. I do care about the correct quadrants. I do care that my reference angles are with the x-axis. So, what are these angles that we're looking for? This one here would be pi minus 1.37. It's less than pi. Like, obviously, it's less than 180 degrees. So that gives us 1.77. The next one, we've got this one here. That's 2 pi minus 1.37. It's a little less than a full revolution. And again, throw that into your calculator. You can get 4.91. Those are the answers in the first revolution. If you want to turn it into a general solution, just add a 2 pi n to each of them. Now, there is a fancy property that happens with tangent. These two solutions are guaranteed to be 180 degrees apart from each other. So if you want to, you can do your general solution this way. It's just the first one, and it recurs, instead of having two of them that recur every 360 degrees, it's just that first one recurring every pi, or 180 degrees. You get full marks for writing it this way. You get full marks for writing it this way. Totally up to you, but it is a neat thing to notice. One last one. Cotangent of theta equals 2. So again, we're going to want to rewrite this in terms of primary trig ratios. 1 over tan equals 2 over 1. Everything's secretly a fraction over 1. So tan theta is 1 over 2. And we're ready to roll. Reference angle. That's what inverse trig is for, if we're in the calculator part. Otherwise, we'd probably use our unit circle. 0.464. You can imagine times before calculators, maybe a good way to find this would be to use a really accurate unit circle, or one that's done on a grid. Anyways, those days are past. We're going to choose our quadrants. Okay. So right over here, tan is positive, so that's quadrants 1 and 3. I'm going to draw my answers. And 0.464 looks like this. And this. Okay, and now I'm going to write my answers. In the positive direction, I can hit this one right here at 0.464. I can hit this one right here at pi plus 0.464, which is 3.61. And that's as far as I can go in the forward direction. This is one revolution. I'm also allowed to go backwards a half revolution, or 180 degrees. Let's see, will I run into a solution if I do that? Go backwards. Oh, geez. Yeah, you do. And how big is that angle? Well, it's definitely less than pi. It's pi minus 0.464. That's its bigness. We're about 2.68. But it's in the negative direction, so the whole thing is going to be negative in the end. Honestly, I would just find its bigness and then make the whole thing negative. Again, you can check these answers. You can see if the tangent of negative 2.68 gives you a half, like here. You can do the same for 0.464 and for 3.61. But those are all the solutions we're going to run into in that restricted domain. I hope you found this helpful. Again, there are links in the description below, both to PDFs and to other potentially helpful videos. Good luck with the material, folks. Take care.